This is Coach Meidenbauer. Welcome to AP Pre-Calculus section 4.7. We're going to parameterize implicit functions, really, and explicit functions as well. You can have directions up top there and how to do that. Essentially, what we're going to do is we're going to look at the implicit equations or explicit equations. We're going to solve for one of the variables, choose the parameter, express the variables in terms of the parameters, and then verify. I'm not going to verify these, but you can always verify these yourself just by plugging them in or even using Desmos to see if they match. So here we go. Here's the first one we're going to talk about. Okay, so this equation, y equals x squared plus 2x minus 1. What we're going to do here is we're going to pick our parameters. So I'm going to let x equal t. It's the easiest parameter to pick. Nope. Okay, so when I do that, and I plug that in for y, it's already set up very nicely for me. So we're substituting out all the x's for t's gives me t squared plus 2t. Oh boy. Oh boy. Plus 2t minus 1. Okay, so our final answer here is going to be t comma and then t squared plus 2t. I apologize for this difficulty here with the stylus. Wouldn't be a Meidenbauer video here on Cami without some stylus issues, right? That's as simple as that problem is. Okay, that's it. Let x equal t and do that. I do want to play a little bit of a what if game. So, what if I can't even write the words what if? I think we're finding out what happens. I can't write the words what if. Oh, there we go. So what if, what is that last line for? What if we do this? What if we instead we let x equal t plus 1. Let's see that we're handcuffed and then we have to let t equal or x equals t plus 1. All we're going to do then is replace all the x's in that y equation, which are up here. So that it becomes t plus 1 squared. Plus 2 t plus 1. And then minus 1. Expand that and solve. I'm going to tell you right now that this is equivalent to t squared. I'll do some of the hard work for you. T squared plus 4t plus 2. Okay, so then you're going to get an answer of t plus 1, t squared plus 4t plus 2. All right, there you go. Blue and red are the exact same thing. If you were to graph into Desmos, the t's might be the times might be different, the parameters within the t's, but this is an infinite one, so you get the same thing. Those are both parabolas. All right. Oh, having some freezing. Parameterize the inverse of f of x. So what we're going to do real quick is we're going to solve for the inverse. So this is x, this is y equals I don't know why I equals right now. Let me go ahead and fix this. All right, so y equals root x. If I want to solve for the inverse, I'm going to solve for x, square both sides. So you're going to get x to equal y squared. Okay. And this is only true when y is bigger than or equal to 0. Because this has a domain restriction, the inverse also has a restriction as well. So that's important to note before we do the inverse. So if we're just doing the regular, we're going to let, there's two different ways to do this. So we're going to let y equal t instead of x this case. When we do that, x is going to equal t squared. So we're just switching the roles for the inverses here. So we're going to get t squared, comma, t. And this is when t, oh boy. This is when t bigger than or equal to 0. All right, because we have that restriction right there. So that'll be the, this is the regular way to do it. And then the inverse of this is when we just switch x and y. So the inverse is going to be switch x and y, t, comma, t squared. All right. And again, let's go ahead and limit our t's here. So we're going to let t equal to 0. Okay, so we first parameterize the regular way. I do it as just an inverse and you just flip them. Not a big deal. Okay. All right, so now we're going to deal with some implicit equations now. Some formulas that we can note here is if we have an ellipse that's centered at hk, here are our parametric equations to use that. So h and k represent the center. A is how much being stretched in the x direction. B is the stretched in the vertical direction, the y direction. And then for hyperbola, they only give you the, this is the horizontal equation. So this is horizontal. Okay, both of these are horizontal. If you ever want the vertical, you're going to switch the secant of t and tangent of t. All right, so if you want to, you can switch those. Let me fix that. We're adding a bit here. Okay. All right. Okay, so for, first example here, I believe there's not enough information. I think we need to give a little bit more for that. So print out these brand new notes. They are not completely fixed. So we need to, I'm going to call this a horizontal ellipse. That way I can actually solve this problem. So parameterize the horizontal ellipse with a semi-major axis length of 6, semi-minor axis length of 2, and the center at the origin. So we're not doing the whole major axis, we're just doing part of it, which is really just half of it. So if I were to sketch this out so I can have a bit of a picture here. Centered at the origin, that means my h comma k is 0, 0. Okay, so if I'm horizontal and I'm going out 6, this way, because I'm a horizontal ellipse, and then the vertical is going up 2. That gives me the equation of x squared over 36 plus y squared over 4, because I'm taking 6 squaring it, 2 squaring it. So now let's go ahead and write this out as parametric equations over here. So my h and k are just 0, so my a value is going horizontal. This is going to be just 6 sine of t. And then y is going to be 2 cosine of t. All right. Parameterize the parabola with the vertices of plus and minus 4, 0, center at the origin, and a conjugate axis length of 4. Conjugate axis length is the It's like I don't want to say minor axis length. Minor axis length is always lower, but it's the length of the negative in the hyperbola. I'll just explain it when we get there. Okay, so we have center and origin, and we have a vertices at 4 out here. 4 out here. So this is clearly a x squared minus y squared equals 1. That should have been equals 1 up here as well. Equals 1. So in the x direction, we're going out 4, so that's going to be 16 because those are vertices. I know that this is going to be horizontal. And then the conjugate axis length represents the co-vertices, the length from the co-vertices here, even though we don't technically have co-vertices because the ellipse does not touch them. That's the mental thinking of that. So the conjugate axis length is 4. That means we're going up and down 2 in this direction. So that's going to be a 4 right there. So now my equations here for my parametric equations are going to be 4 in the x direction, so it's 4 secant of t, and then y of t is 2 tangent of t. All right, so we're going to wrap that video. Again, there's different ways you can write these answers for all of these. Like this one up for example 3, I just did x equals y equals. I did x of t, y of t, they're the same thing. And on these up here, I put those in the actual parentheses because we've seen it that way. So just different ways to answer these same exact questions. That's going to wrap up our video. Do not forget to like and subscribe.